Hello, I'm Hans H. Stein, and I'm a professor in the Division of Nutritional Sciences and the Department of Animal Sciences at the University of Illinois in Urbana. I would like to talk to you today about some work we have conducted to determine requirements for digestible calcium by growing pigs. And the take-home messages I hope I can leave you with this afternoon is, number one, that according to the results of our research, we believe that excess calcium in the diet is detrimental to growth performance of growing pigs, and I'll show you some data that leads us to that conclusion. Secondly, we also believe that the requirements for calcium should be expressed as requirements for standardized total tract digestible calcium instead of requirements for total calcium. We also have data that would indicate that there is storage of calcium in tissues in the body other than bone, and I will try to demonstrate that by showing you some data on calcium retention. And finally, requirements for growth is less than requirements for bone ash, so a pig can maximize growth on concentrations of digestible calcium that are less than what is needed to maximize bone ash. That also indicates that bone ash is not necessarily the best response variable to measure when we determine digestible calcium requirements. What really got us interested in determining requirements for calcium were results of an experiment we conducted several years ago. In this experiment, we had the same concentration of phosphorus in 6 different diets, but we increased the concentration of calcium in these diets. So the lowest concentration was 0.33%, and then we gradually increased that concentration up to 1.04%. And as is indicated here, we reduced the digestibility of phosphorus as we increased the concentration of calcium in the diet. And that was unexpected, but that indicates that calcium has a negative effect on the digestibility of phosphorus. And that was really what got us started in this work, and that indicated that the inclusion of calcium in diets for pigs is important because we need to make sure we don't reduce the digestibility of phosphorus. If we look at calcium requirements for pigs and how those requirements currently are expressed, we'll notice that if we look into NRC, there are requirements for different weight groups of pigs. And in this case, we have a pig from 100 to 125 kilogram, and NRC indicates that the requirement for total calcium is 0.46% in the diet. And at the same time, the requirement for standardized total tract digestible phosphorus in a 100 to 125 kilogram pig is 0.21%. So the question is, how did NRC come up with these values? Well, it is described in the NRC book how these values were calculated. And these values are derived from the body protein of pigs. And body protein is then converted to body phosphorus mass because there is a linear relationship between the phosphorus that is deposited in the body of a pig and the protein. So if we know total protein mass in the pig, we can calculate total phosphorus mass. From there, the requirement for standardized total tract digestible phosphorus was calculated because it was assumed there's a constant efficiency of utilization of phosphorus for retention into body phosphorus mass. And from the requirement for digestible phosphorus, the requirement for total calcium was calculated simply by multiplying the phosphorus requirement by 2.15. And the factor of 2.15 was, at best, an estimate based on empirical results obtained, but there were very few data to back this number. But this is how all the requirement data for calcium by NRC were calculated. Now, if we look further into NRC, the committee who developed the NRC requirements acknowledged that there was not much data to base the calcium requirements on. And the committee wrote in the NRC requirement book that it would have been preferred to have a ratio between digestible calcium and digestible phosphorus for the calcium requirement. But because there is a lack of data, that it was not possible to give requirements for calcium as requirements for digestible calcium, and therefore the ratio between total calcium and digestible phosphorus was used. So what the committee here really is saying is that we realize that this is not necessarily the best way of estimating requirements for calcium, but it is the best we could do with the data that are available. So based on what was written in the NRC book, we decided at the University of Illinois that we wanted to develop data for requirements for digestible calcium by growing pigs. So the first thing we had to do was to determine the standardized total tract digestibility of calcium in inorganic calcium sources such as limestone and calcium carbonate and calcium phosphates. We also determined the standardized total tract digestibility of calcium in plant ingredients that contain calcium. There's not a lot of plant ingredients that contain calcium, but there are a few, and we determined the digestibility in those ingredients. We also determined the standardized total tract digestibility of calcium in animal proteins, such as milk proteins and fish meal and meat and bone meal. And finally, having all these data, we were able to formulate diets based on concentrations of standardized total tract digestible calcium, because now we had developed these data for all the feed ingredients that we include in our diets. So, having these data, we formulated diets for pigs from 11 to 25 kilograms. And in this case, we had 6 diets containing different concentrations of digestible calcium. So here we go from 0.32% and up to 0.72% digestible calcium. And those values correspond to concentrations of total calcium of 0.40 to 1.07% of the diet. So we assumed we were well below the requirement for the lowest concentrations of calcium and well above the requirement for the highest concentrations. We then fed these 6 diets to pigs that were growing from 11 to 25 kilograms, so they were receiving these diets for 22 days. We had 4 pigs per pen, and at the end of the period, we killed 1 pig per pen and removed the femurs so we could determine bone ash in these pigs. We also determined gross performance of the pigs over the 22-day period. We also fed these 6 diets to pigs in metabolism crates, and that allowed us to do total calcium and phosphorus balances of these diets, and that also allowed us to calculate the retention of calcium and phosphorus in the body of these pigs. So, if we look at the results from this experiment, we first look at bone ash here from the pigs that were fed these 6 diets for 22 days, and this is bone ash in the femurs, and we will see as we have a low concentration of digestible calcium in the diet, we have a low concentration of bone ash in the body. But as we increase calcium, we increase the concentration of bone ash, and this is pretty much what we would expect, and we have a break point here that is about 0.48% digestible calcium in the diet. So these data would indicate that to maximize bone ash in pigs between 11 and 25 kilograms, we need 0.48% digestible calcium. If you look at data for calcium retention, you'll see the curve is a little bit different, but not too much different. And in this case, we have the intersection between the quadratic and the linear breakpoint analysis at approximately 0.60%, indicating this might be the requirement to maximize calcium retention in the diet. And you'll notice here that the requirement to maximize calcium retention is a little bit greater than the requirement we saw before to maximize bone ash in the body. But again, we saw a classical response pretty much the way we expected it. If we looked at phosphorus retention, same story. As we increased calcium in the diet, we increased retention of phosphorus in the body, presumably because it takes both calcium and phosphorus to deposit bones. So as we increase calcium, it's possible for the pig to utilize more phosphorus and retain more phosphorus in the bones. And again, in this case, we have a break point of about 0.48% standardized total tract digestible calcium in the diet. So until now, things looked pretty much the way we expected it. However, when we looked at gross performance, the curve changed. And here we will see that as we increased calcium in the diet, we started to see a reduction in growth performance. There was no negative effects of having low concentrations of calcium in the diet, but if we got to the greatest level of digestible calcium in the diet, we had a reduction in average daily gain. And in this case, we can say that we should not exceed 0.54% digestible calcium in the diet, because if we have greater concentrations, we will start to see a reduction in average daily gain of these pigs. When we look at gain to feed, we saw a similar curve, and in this case, we believe that we should not exceed 0.50% digestible calcium in the diet before we start seeing a reduction in the gain to feed ratio. So we were not able to, in this experiment, to determine the minimum requirement for calcium in diets for 11 to 25 kilogram pigs, but what we did determine was that the maximum calcium that should be in these diets is about 0.50% digestible calcium. If we look at the data in a different way, we saw that the bone ash was maximized at 0.48% digestible calcium, bone calcium was maximized at 0.50% digestible calcium, calcium retention was maximized at 0.60%, and phosphorus retention was maximized at 0.48% digestible calcium. We had the same concentration of phosphorus in all diets. So these requirement estimates here, based on bone ash, bone calcium, and calcium and phosphorus retention, indicates a requirement that is less than or maximum of 1.33 to 1 and up to 1.67 to 1, meaning for every unit of phosphorus, we should have no more than 1.33 to 1.67% digestible calcium. In these data are in pretty good agreement with previous estimates of the concentrations of calcium and phosphorus in the empty body of pigs at 25 kilograms. There's been a number of experiments published with those data, and the results of those experiments have indicated that the calcium to phosphorus ratio in the body of a 25 kilogram pig is between 1.20 to 1 and 1.60 to 1. So most of the data we obtained were right in that range. However, as I mentioned, we were not able to determine the requirement for digestible calcium by 11 to 25 kilogram pigs in this experiment as we had expected. The only thing we were able to determine was that the maximum concentration of calcium should not exceed the numbers we have above here. So from there, we decided to determine the calcium requirements for 25 to 50 kilogram pigs. And in this case, we used 20 different diets because we realized that the ratios between calcium and phosphorus is maybe more important than the actual calcium concentration in the diet. So we had 5 different concentrations of digestible calcium between 0.13% and up to 0.72%. And again, we assumed that was well below the requirement, and we're going up to concentration that is well above the requirement for digestible calcium by these pigs. We had 4 different concentrations of digestible phosphorus in these diets: 0.15, 0.31, 0.39, and 0.47%. And again, this is going from below the requirement to above the requirement. And for each of these diets, we calculated the ratio between digestible calcium and digestible phosphorus. So in the first diet, we had a ratio of 0.87. And when we increased calcium, we had a ratio of 1.80 to 1. When we increased calcium more, we got to 2.80 to 1 and so forth. And because the NRC requirements for digestible phosphorus for 25 to 50 kilogram pigs is 0.31%, and the calcium requirement, which is based on total calcium, but if we convert that to digestible calcium, is approximately 0.42%, we can see here that the ratio in the middle of 1.35 to 1 between digestible calcium and digestible phosphorus is where the NRC requirement is. So we fed these 20 diets to growing pigs. We had 2 pigs per pen, and we also fed them to pigs in metabolism crates so we could determine the calcium balance and the phosphorus balance and calcium retention. And as we did in the first experiment, we killed 1 pig per pen at the end of the experiment so we could remove the femurs and determine bone ash. Here are some data from the experiment. The red lines include the 5 diets that contain 0.15% digestible phosphorus. And then we have the increasing concentrations of digestible calcium along that line. The black line are for the 5 diets that contain 0.31% digestible phosphorus, and again with 5 different concentrations of digestible calcium. The blue line are the diets with 0.39% digestible phosphorus, and the green line are the diets with 0.47% digestible phosphorus. And what we'll see here is that at the lowest phosphorus concentration, at 0.15%, we see a negative effect of increasing digestible calcium in the diet. So as digestible calcium is increased, we see a reduction in body weight on day 28. If you look at the black line, which is 0.31% digestible phosphorus, we'll see that for the first 3 concentrations of digestible calcium, there's not really much change, but then as we add more calcium to the diet, we start seeing a reduction in body weight. And then for the blue lines and the green lines, where we have the higher concentrations of digestible phosphorus, there's really not much negative effect as we increase calcium in the diet. If we look at it in a different way, we can see after 28 days, there was a difference in the body weight between the pigs fed the lowest and the highest concentration of phosphorus and the greatest concentration of digestible calcium of 13.6 kilogram. So clearly the pigs with the high concentration of calcium and a low phosphorus concentration were hurting. They were not growing very well. And in fact, if we look at the pigs, we can see here the pig to the left was on the high calcium diet. The 2 pigs on the right were on the low calcium diet, and it's easy to tell that there was a difference here and that the pigs on the high calcium diet did not do very well as compared to the pigs on the low calcium diets. If we look at average daily gain, we got a very similar picture as for body weight. We see a clear reduction in average daily gain as we increase digestible calcium in the diet, in particular if we have low phosphorus in that diet. So the red line has a very negative slope here because the more calcium we have in the diet, the lower is the average daily gain. However, if we look at the black line, again, the first 3 concentrations of digestible calcium does not cause much change, but as we increase above the 3rd level, we start seeing a reduction in average daily gain. And then for the 2 highest levels of digestible phosphorus, there's not as much negative effect of calcium on average daily gain. So the conclusion here is that if we have low or marginal concentrations of phosphorus in the diet, increasing digestible calcium is really detrimental to growth. However, if we include phosphorus above the requirements, it is not detrimental to increase digestible calcium in the diet. For gain to feed, we had a very similar response with a reduction in gain to feed for pigs fed the low phosphorus diets, and also to some degree for pigs fed the diet with 0.31% phosphorus. But if we have phosphorus in the diets above the requirements, which is indicated here by the blue and the green lines, then we did not see this negative effect of adding extra calcium to the diets. Bone ash was a little bit different. We did not see the negative response to adding extra calcium in the diets, except when we got to the highest level of calcium for the low phosphorus diets. But if we had 0.31, 0.39, or 0.47% digestible phosphorus in the diets, there were really no negative effects of adding extra calcium to the diets. So even though we saw on the previous slides that growth performance was reduced when we added high concentrations of calcium to the diets, that did not translate into a reduction in bone ash. Retention of calcium in the body, here we see again a different picture because regardless of the concentration of phosphorus in the body, we actually saw an increase in retained calcium in the body. And this is from the pigs in metabolism crates, where we measured intake and output of calcium from all the pigs. So based on these results, and comparing to the previous slide for bone ash, it appears that retention of calcium has a greater response to digestible calcium in the diet, and that indicates that some of this calcium must have been retained in tissues other than the bones. And that is a little bit surprising because usually we have believed that most of the calcium is deposited in the bones, but these data indicate that there must be retention in some tissues other than bones. Otherwise, we would not see these curves for calcium retention. So having obtained these results for 25 to 50 kilogram pigs, we decided to conduct one more experiment, this time with 100 to 130 kilogram pigs. In this case, we used 15 different diets. Again, we had 5 different concentrations of calcium from 0.12 to 0.78% total calcium, which translates to 0.08 to 0.49% digestible calcium. We had 3 different concentrations of phosphorus in this experiment, 0.11, 0.21, and 0.31% standardized total tract digestible phosphorus. And the NRC requirement for total calcium for 100 to 125 kilogram pigs is 0.46%. The NRC requirement for standardized total tract digestible phosphorus is 0.21%. So the combination of those 2 concentrations would give us the requirement for calcium and phosphorus. The 15 different diets we formulated allowed us to calculate the ratio between digestible calcium and digestible phosphorus. And if we start with the diet with 0.08% digestible calcium and 0.31% digestible phosphorus, we had a ratio of 0.26 to 1 between digestible calcium and digestible phosphorus. However, as we reduced phosphorus in the diet or as we increased calcium in the diet, that ratio increased, and the greatest ratio was for the diet with the highest concentration of calcium, 0.49% digestible calcium, and the lowest concentration of phosphorus, which was 0.11% digestible phosphorus. And in this diet, we had a ratio of 4.45 to 1. And then all the other diets were in between these 2 extremes. And we will see that for the diet that supposedly met the requirement for total calcium and digestible phosphorus, according to NRC, we had a ratio between digestible calcium and digestible phosphorus of 1.38 to 1. We fed these diets to the pigs for 4 weeks, and we then killed the pigs, and we again determined bone ash, and these pigs were individually penned. And in this experiment, we used a modeling approach to estimate the requirements. And what you will see here is that as we increased calcium in the diets, we saw a linear reduction in average daily feed intake regardless of the concentration of digestible phosphorus in these diets. And the modeling we conducted resulted in an equation that allowed us to predict feed intake, and we have that equation indicated here as 3.6782 minus 1.2722 times digestible calcium in the diet. So because there's a negative sign in front of the digestible calcium, that indicates there's a negative slope to the regression line, and that is why we can see that as we increase calcium in the diet, we reduced feed intake of the pigs regardless of phosphorus in the diet. And we'll see that there's no estimate for the phosphorus in the equation, which again indicates that phosphorus did not have any impact on the feed intake of these pigs. It was all driven by the digestible calcium in the diet. If we looked at average daily gain, same picture here. We had the regression equation was 1.2141 minus 0.0635 times the digestible calcium in the diet. So again, we see there's no impact of phosphorus on the estimated average daily gain. So average daily gain is only determined by the concentration of digestible calcium in the diet. And again, we have the negative sign in front of calcium, indicating that the more calcium we have in the diet, the lower is the average daily gain. And that is also easy to see on this regression line because there's a very significant negative slope on the regression line, indicating that the more digestible calcium we add to the diet, the slower is the growth of these pigs. And we get the greatest average daily gain at the lowest concentration of calcium in the diets. We also tried to model the gain to feed in these pigs, but these data were less clear than the data for feed intake and average daily gain, and in fact it was not possible to predict gain to feed from the intake of digestible calcium or digestible phosphorus. So in this case, we did not have a clear response on gain to feed of the pigs as we increased calcium in the diet. We also modeled deposition of bone ash, and we have the equation here, and we'll see we have a small negative number in front of digestible calcium. We have a small negative number in front of digestible phosphorus, but then we have a much larger positive number in front of the interaction between digestible calcium and digestible phosphorus. So what this indicates is that it takes both calcium and phosphorus to deposit bone ash, which is exactly what we would expect, and that is also in agreement with what we have seen in the previous experiments. So whereas we only needed calcium to predict average daily gain and average daily feed intake, we clearly need both intake of phosphorus and intake of calcium to predict the deposition of bone ash in these pigs. So that is in agreement with what we would expect. So in conclusion, we have seen that excess calcium reduces average daily gain and gain to feed, and in one experiment we also saw a reduction in average daily feed intake as we increased digestible calcium in the diet. The most negative effect is observed if digestible phosphorus is marginal or below the requirement, whereas if we have excess phosphorus in the diet, we don't see the negative effect of extra calcium in the diet. We've also seen that the requirements to maximize bone ash is greater than the requirements to maximize gain, and that indicates that if the objective is to maximize bone ash, we will need to add more calcium and phosphorus to the diets. So a few recommendations here at the end. First, we have seen that pigs that are less than 50 kilograms, they will have reduced growth performance if we increase calcium in the diets above what is needed to maximize gain. We have not determined the absolute requirement in these pigs, but we believe that at this point, the ratio between the standardized total tract digestible calcium and the standardized total tract digestible phosphorus should be less than 1.25 to 1. For pigs that are greater than 100 kilograms, we believe the ratio should be less than 1.10 to 1 because these pigs appear to have a lower requirement for calcium relative to phosphorus than in the smaller pigs. However, because we see a maximum bone ash at greater concentrations of calcium and phosphorus than is needed to maximize gain, it is possible that developing gills and developing boars may need greater ratios between calcium and phosphorus than terminal pigs. However, we have not conducted research in this area, so at this point we don't have any data for these animals. What is some of the future research that needs to be conducted? First of all, I want to point out that all the experiments we have conducted so far have been short-term experiments, and we therefore need to verify our results in wean-to-finish experiments. So we need to make sure that the data we get in these individual time periods from 25 to 50 or 50 to 75 kilogram pigs, they also are the correct estimates for the requirement if we feed pigs all the way from wean to finish based on these requirements. So that's one thing we need to have done. Another thing we need to have done is we have done quite a bit of work to estimate the effects of microbial phytase on digestibility values for calcium in feed ingredients. But at this point, we need to verify these values in particular in mixed diets, and that's something we have not had time to do yet. And finally, we need to determine the digestibility of calcium in feed ingredients fed to gilts and sows, and we need to determine if the digestibility in these animals is different from the digestibility in growing pigs as we have used so far. And then we also need to determine requirements for digestible calcium in gilts and sows, and that's something we have not determined yet. And with this, I want to acknowledge the financial support we have received for this work that has primarily been from AB Vista, and we are grateful for their support. And I also want to acknowledge all the work that my graduate students and technicians have done to develop these data. Finally, I want to point out that all our research reports, all our publications, all our press releases, etc. are available on our website, nutrition.ansci.illinois.edu. Thank you very much for listening.